in a May Lead Code challenge, we have a problem of find the town judge. The problem statement says that in a town there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. And the second point is everybody except for the town judge trusts the town judge. And third, there is exactly one person that satisfies properties 1 and 2. You are given trust, an array of pair. Trust I is equal to A and B, representing that a person labeled A trusts a person labeled B. If the town judge exists and can be identified, return the label of the town judge. Otherwise, return -1. Example 1 is we have an input n is equal to 2 and the trust is 1. One has a 1 pair which says 1 and 2. It means 1 trust upon 2, and the output is 2 because 2 is trusted by 1 and it doesn't trust anyone. In example 2, input is n is equal to 3 and the trust is 1. The first pair is 1 and 3. 1 trust 3 and the second one is 2 trust 3. So 3 is the person who is trusted with 1 and 2 and he doesn't trust anybody, so the output would be 3. In the example 3, n is equal to 3, trust is equal to, the first pair is 1 3, 1 trust 3, second one is 2 trust 3 and the third one is 3 trust 1. We can see that 3 is trusted by 1 and 2, but 3 also trust 1. In case of town judge doesn't trust anyone, so there is no one who is trusted by all and who doesn't trust anyone else, so the answer would be -1. The fourth example is n is equal to 3, trust is equal to 1 trust on 2 in the first pair and the second pair 2 trust upon 3. I can see that there is not a single person who satisfied both of the condition, so the output is -1. In the example 5, we have n is equal to 4 and trust has following pairs which says 1 trust upon 3, 1 trust upon 4, 2 trust upon 3, 2 trust upon 4 and 4 trust upon 3, and the output is 3. And the note says that n is between 1 and 1000, okay, and trust length is less than 10,000, and the trust I are all different. That's nice to know, it's always unique. Trust I0 is never equal to trust I1. It means a person itself never trust himself, and trust I0 and I1 is always between 1 and n. These are 4 conditions which are pretty okay and understandable. Let's start with the solution. Okay, how do we proceed for this solution? uh, let's start with the example, this one, the last example. The first trust, my approach would be to maintain a hash map, I trust and other trust. I trust will be someone who says which key trust upon which person trust upon which person. The key will be always the label, and the value would be the list array which will give all the person whom the key trust upon. For example, in the example above, the map would for one would be, let's start with one. One trusts upon 3 4, one trusts upon 3 and 4, yeah, and two trust upon 3 and 4, and 4 trust upon 3, and 3 is the one who doesn't trust anyone, so we don't have key for that. In the other trust, what would happen for the above example? Other trust, when I will start with 3, and what are the people who trust upon 3? So it would be 1 and 2 and 4. For the second case, for the 4, what are the people who trust upon 4? And we see that it's 1 and then 2 and that's it. And who are the person who trust upon 1? I don't see any people who are trusting upon 1. Who are the people who are trusting upon 3? I see that no one is the no one no sorry 2. So no one is there whom 2 trusts. Sorry, no one is there. No, there is no there is no person who is trusted, uh, whom 3 trusts. Sorry, who trusts 3? Okay. So we have 2 condition here. The first condition is I trust. The first condition is the first condition is the town judge is trusted by all. So number of people trusting him is n minus 1 except him. Second number is a town judge is not trusted. Town judge is not doesn't trust anyone. Sorry, doesn't trust anyone. Doesn't trust anyone. It means we don't have any key in I trust. Any key in I trust map. Let's start with the implementation. First we will create these 2 hash maps, and then we will check these 2 criteria there, and it should be fine. There is one special case in this. What happens if the town has only one person? In that case, n is equal to 1, and it doesn't have anything inside the array because this inside the array of trust, because he doesn't trust anyone. He is a single person in a town. So this is a special case which we'll keep in mind when we will write the code. Let's start with the implementation first. Let's declare I trust. Sorry, it should be an empty object. Oh. Yeah, and then let's start with equal to this, and let's start with the implementation. Let I is equal to 0. We need to declare one more variable, which is a town judge, and which default value is -1. For I is equal to 0, I less than I plus. Yes, I will declare a variable trusty, so that I don't have to write it again and again. Trustee is someone who trusts others, so it will be I and the first element of the pair, and second one is the trusted. Trusted is someone who is trusted upon, and it will be the first pair. So let's start with the implementation of I trust. I trust is equal to trustee will be key here is equal to I. If it exists, then I will simply concat the, if it already existing, then I will simply concat trusted in this, and if it doesn't exist, I will just add it here. Now let's build the other trust object which contains all the people who are trusted upon, and for that I, same as above, I need to check first if it exists. If it exists sorry, concat trust I and 0, and if it doesn't exist, I will simply make it the first element of an array. Yeah, I can actually make it trustee. I will concat the trustee and I will add a trustee. Here I will make this trusted and it will be trusted. Good. After this for loop, we will be ready with all the I will be ready with the I trust and other trust object. I will make an array out of the keys of object dot keys, and I will make key array out of other trust. And then I will make a for loop which will loop through all the keys I less than key array and let the current is equal to key array, Ctrl J, Ctrl C, and then I. If now we have to satisfy these two conditions which we have discussed, so let's start with the other trusts, and current if it exists, and if dot length is equal to n minus 1, and town has only one, town doesn't trust anyone, town just doesn't trust anyone. For that condition to satisfy, we need to make trust check that I trust doesn't contain this value. It means just doesn't trust anyone, and if it is true, then I will assign trust judge to current, and after this I will return town judge. Okay, we are done with the implementation except the special case when the town has just one person and he is the town judge. In that case, we simply have to have a return statement if n is equal to 1 and trust doesn't have anything, is equal to return. In that case, we just return 1. That's it. Let's try running the code. Yeah, this was the first example. Let's try with the second example. 3. Okay, let's try with the third example. Well, it works fine. And then let's start with the fourth example. N is equal to 3. Okay, and let's start with the fifth example. What is the value of n here? N is equal to 4. Yeah, let's try to submit it. This is accepted. Yeah, the 89 of 89 test cases are passed. And okay, I like this solution. It's a easy solution. It just uses two hash maps, and then we just check the conditions out of it. How do you like this solution? Let me know, and see you next time. Bye bye.